They must be insane. So they made this crazy problem. The function f(x) defined for positive x and the quartic function gx of which leading coefficient is -1 specify the conditions below. A is a constant. A. For all real numbers x greater than a, x minus a times fx equals gx. B. For two different real numbers, alpha and beta, the function fx has the same local maximum value m at x equals alpha and x equals beta, where m is a positive number. C. The number of x's which make fx local maximum or minimum is greater than that of x's which make gx local maximum or minimum. And beta minus alpha equals 6 times square root of 3. Then find the minimum value of m. The problem says two functions fx and gx is related like this, and f is defined by gx and x minus a as a fractional function or rational function. And there are another conditions. F alpha equals f beta equals m, and f prime alpha and f prime beta is 0, since alpha f alpha and beta f beta are local maximum points. So we can sketch fx as like this. Y equals fx. There are positive number m line parallel to x-axis. So this is y equals m. And a alpha beta, there are 2 points that are bigger than a. We can sketch the local maximum points like this. We only know the local behavior of y equals fx, and the other behavior of the function is still not known. And the additional condition says beta minus alpha equals 6 times square root of 3. From this condition, we continue to find out what gx is. And gx, rewrite it as x minus a times fx. And plug in alpha and beta to gx. And g alpha equals alpha minus a times f alpha equals m alpha minus a. And g beta equals beta minus a times f beta is m times beta minus a. And we differentiate gx. So g prime x equals fx plus x minus a times f prime x. Again, we plug in alpha and beta to the derivative function of gx, g prime x, then we get g prime alpha equals f alpha plus alpha minus a times f prime alpha. It looks complex, but since f prime alpha equals 0, g prime alpha is only n, and g prime beta is also f beta plus beta minus a times f prime beta equals n. These relations are what we have found by using this relation and these values for x, f, and f prime x. There's another thing to check. We will find the slope of the segment alpha g alpha and beta g beta is beta minus alpha g beta minus g alpha m beta minus a minus m alpha minus a divided by beta minus alpha, and it can be simplified to m beta minus alpha. So the slope of the line segment is m, and using these conditions we have found so far, we can try to sketch what gx looks like. It is given that gx is a quartic polynomial with the leading term of minus x to fourth. So we sketch the function like this. Since g prime alpha equals m and g prime beta equals n, and the slope of the line segment of these 2 points is also capital M, we can draw a line connecting these 2 points, and gx is tangential to this line at alpha, g alpha, and g beta, and it go back to minus infinity at both sides. But we have to decide or find out what is the correct behavior of this gx function, this function y equals gx. It means it can rise up to the maximum point and going down to the minimum, local minimum, and then go up again to maximum, or it can stay a while and then continue to rise up, or even it can rise up without even staying, and it continued to grow to the only maximum points. So there are 3 possibilities of this function, and we have to decide which one is right to the requirement of the problem. That is our big task. But there is one thing we know. This line segment is tangential to alpha G alpha and beta G beta. So if the slope changes, the shape of Gx can also change accordingly. To take advantage of the fact, we introduce a function h prime x equals g prime x minus m, or h x equals g x minus m x plus c, and c is a sort of constant of integration to be defined later. And we require the fact that h alpha equals g alpha minus m x plus c equals 0, g alpha, and h beta equals g beta minus m, no, I made a mistake, alpha beta plus c equals 0. Since g alpha equals m times alpha minus a, if c is m a, the requirements are satisfied. So we can sketch the newly introduced function hx. It is 0 at alpha, at x equals alpha, and at x equals beta. But it is also a quartic function that is equal to the second power of gx. It differs only linear term and the constants. So it behaves also like gx. It goes down to minus infinity at both sides. And from the sketch, we can guess the form of hx. Since hx is 0 at x equals alpha and beta, it must contain factors of x minus alpha and x minus beta. But the sign of the leading term must be minus, but it cannot be linear factor because it is tangent to the x-axis like this, and additionally it is tangent to x-axis at x equals alpha and beta. So from this we can write down what gx is. Gx is equals minus x minus square times x minus beta squared plus m x minus a. This is what we have found as gx. For now, let us interpret this function. This function is hx plus a linear function, which is this line. So gx go back to hx when m is 0. And if we change the slope of the line m, then the whole shape can change from type 1 to 2 or type 3. So the problem also says there are less number of extremum points in G than fx. We should determine how many local maximum or minimum points there are in fx. So we go back to fx. Fx equals gx divided x minus a. We are tempted to substitute gx as a polynomial form, but doing that leads to very lousy calculation and more time. So we continue to using this relation, and to decide how many extremum points we differentiate fx. F times x equals g prime x times x minus a minus gx divided by x minus a square. And we rename the numerator part as nx, and g prime x, x minus a minus gx. And go on to find the zeros of nx. That is, they are the solutions of nx equals 0. To do that, first we find out what nx is by considering only the leading terms of this function. G prime x equals minus 4x to third. The leading terms of nx equals minus 4x to fourth minus x to fourth. Then it is minus 3 times x to fourth. So it's also a quartic function, and the equation can have at most 4 real number solutions. From the facts fx is of this type, we can temporarily conclude there are at least 2 solutions in nx equals 0, and n alpha equals g prime alpha times alpha minus a minus g alpha is 0, and g beta n of beta equals g prime beta times beta minus a minus g beta is also 0. So we sketch nx like this: alpha and beta. Since n alpha and n beta equals 0, the quartic polynomial behaves like this because alpha f alpha and beta alpha beta is local maximum, and nx comes from the derivative function of fx, so the value means the slope of the tangential lines. So the tangential lines changes from positive to negative. Positive to negative. It changes from positive to negative, positive to negative. And we have only found two solutions, but nx is since nx is a polynomial function, it must behave analytically. That means it behaves continuously and smoothly. So it must rise up to positive and reach to the maximum and go back to minus. So we have found three solutions, three real valued solutions, and there are only one left. We can try to guess where it is. If the remaining solution is bigger than beta, then it must go up and down, so it cannot be 1. It must be 2, or even it's tangent to the x-axis, it raised the order of the function to 5. So it cannot be bigger than beta. It cannot be between alpha and beta. There is only one possibility. It must be less than alpha. Even then, there are two possibilities. It go over A0, or it go under A0. It is important because it goes over A. The domain area of fx is bigger than A. It cannot be a proper extremum points. But if it go under A0, there is one more proper extremum point. So to find out which one is right, we substitute A in n, and A is G prime A times A minus G A, then minus G A is plus A minus alpha squared times A minus beta squared minus n A minus A, but it is also 0. So finally we can conclude n A is bigger than 0, positive. It means it goes over A0, and we reached the result that fx has only 3 extremum points. The problem also required that gx must have less number of extremum points than fx. So it can have at most 2 extremum points, but The quadratic function can have one or three extreme points like this, 3 or 1. Even if it stays a while and start to increase again, the extreme points is only 1. This is not extreme points. It is also a monotonic increasing. We can safely say that gx has only one maximum, local maximum point. And it is a true globally maximum point. There is only one task left. To finally find what capital M is, we first differentiate gx. G prime x equals minus 2 times x minus alpha, x minus times x minus beta squared minus 2 times x minus alpha squared times x minus beta plus m. And rewrite this by factoring terms minus 2 x minus alpha, x minus beta, and x minus beta plus x minus alpha plus m. Then it is finally times x minus alpha plus beta divided by 2 plus m. And at this stage we must draw this function and change the value of m and decide how many solutions there are in this equation. So we move these terms to the right side and m remains. Then 4 times x minus alpha, x minus beta, x minus alpha plus beta divided by 2 equals m. We name this left hand side and use these values. Beta minus alpha equals 6 times square root of 3. Then kx equals 4 times x minus alpha times x minus alpha minus 6 times square root of 3 and x minus alpha minus 3 times square root of 3. And replace x minus alpha by t, and we rename this function as LT. Then 4 times t minus 6 times root 3, and t minus 3 times square root of 3. And for the convenience sake, we temporarily replace 3 times square root of 3 as a equals 3 square root of 3. Then LT can be written as t minus 2a times t minus a. Then we sketch this function as 0, a, and 2a, and it is a typical third degree function. And we change the value of m, then there are only one solution at this value and this value. From this value, there are 3 solutions, and the limit it can have only one solution is this value. When m is the local maximum value of LT. So we again find out what this value is. To do that, differentiate LT again, and L prime t equals 4t minus 2a t minus a plus 4t t minus 2a plus 4t t minus a. Then after some organizing, 3t squared minus 6at plus 2a squared, and it must have 2 solutions since it's a quadratic function. So we find what t1 and t2 is. T can be found as 3t minus a squared minus a squared equals 0. T minus a squared equals a squared divided by 3. T minus a equals plus minus a divided by square root of 3, and t equals a plus minus a over square root of 3, and t1, this value t1 is negative sign of this solution. T equals a minus a over square root of 3, and insert back a, then t equals this is what we were searching for. And finally, insert 2 LT, and this must be M. M must be 4 times T1 times T minus 6 times square root of 3 times T minus 3 square root of 3. And we insert back this value T1, so 4 and 12 times Finally, this is 6 cubed. So it is 216. And it's the value of m. And it's the answer. It means it can be bigger or equal to 216. By remembering the sketch of gx, the line passes through A0 and gx is tangent to alpha and beta like this. The line can be changed, m changes. So if the slope decreases, the gx can change like this. And we have found the boundary value, and we finally got the answer. We have come a very long way. This is one of the 30 problems Korean students must solve at CSAT math test in 100 minutes. The time includes the marking time on the OMR card. They had solved this problem under the pressure of time and the burdensomeness of their fate. Since many students feel if they fail at the college entrance test, they failed their life. So even the sadly stupidest students do the very, very wrong things to it means the unmentionable thing to his life. That is so tragic. So even this is my first time lecturing how to solve this kind of most complicated problems in English, even though I'm not a native speaker of English. I challenged this because I want to show how Korean students are suffering for the college entrance exam. I'm not intending to boast that Korean students are a genius at math and they are brilliant. Even the most brilliant students can not solve this problem easily. At the pressure of the atmosphere of the test taking place. So I'm wondering what the professors and high school students that participated in test making process thought of this, the difficulty Did they think this is a proper difficulty for CSAT math test of Korea students? If they did, they are absolutely out of their mind. They must be insane. So they made this crazy problem. I think this is rather torture to the students. It not only harass the students, it also gives the economic burden to each Korean family. In YouTube, there are many kinds of English test problems. Challenge these Korean students CSAT 수능 problem. Look how difficult it is. The insane English problem solved by American people or British people. And they leave their comments and say it's outrageous for students studying as a second language, because the complexity of the reading materials and the vocabularies come from graduate school textbooks is totally outrageous. And it is well known to many English-speaking people. But I also let you know how insane Korean math problems are. That is my intention, explaining how to solve this crazy problem in English. And I'd like to share opinions about this problem and Korean CSAT math problems. If you have another explanation or method of solving this problem, then add your comment. If you find any faults in my method, then please help me correct it. And if you can find a better solution, please let me know. Thank you very much.